with Palace of Westminster, we're looking at the mortar samples specifically. So obviously, as I'm sure most people will be aware, when you have a brick construction, you will have mortar joints between them that's acting as your glue to hold them together. When we look at it, what we like to say is we prepare it, make a thin section out of it, and when we look at it petrographically, what we can do is you can see what the constituents are, what it's made of, and we can tell its condition. So when we report it to the clients, what we do is we'll say what we think, first of all, what we think it's made of, what cement type, what binder they've used. There's a lot of variations, especially in historic mortars, whereas today everything is very standardized. When we get the samples, we embed them with a fluorescent dye resin. Basically, when we use a reflected light, that fluorescent dye gives off a certain amount of color back. In our case, we use green. So when there's a lot of porosity in one area, it takes in a lot of resin, and that obviously gives a very bright light, so in our case a very strong green. And if there's not as much porosity, little dye in there, and therefore a much more muted colour. That is really critical to what we're doing here, because without that light passing through, we don't see any of the optical properties that we would be able to identify them with. So by polarising the light, and by using those polarizing lenses in various angles, the light that comes through that slightly opaque or translucent crystal, it refracts, it bends slightly. And the angle of that, what it bends at, will change what we see through the top of the microscope. The change can help identify the composition of them. So that is really the basis of what petrography is founded on. Though not all things end up being see-through, so certain metallic elements or minerals don't transmit light at all, and they're called opaque. As you might expect, basically it comes down to they're so visually dense, obviously something made out of just metal, much denser than the normal crystals, so they, even when they're made very thin, they still don't pass that light through. And that in itself tells you something, well, tells you quite a lot about what it's made of potentially. You can rule out a vast quantity of other minerals.